In this video, we'll look at transformations of a parabola. So the function given, remember f at x is just like y, so this is an equation, or a function, 2x plus 4 squared minus 1. The first question it's asking for us to do is describe the transformation. I just wrote describe. So I'm going to put my answers down here. A. What are my transformations? Well, you start with the stuff in the brackets, and it says x plus 4 in the brackets, but the transformations would always be the opposite of what's in the brackets. If you see an x plus 4 in here, it's going to be a shift or a translation, except you go the opposite. Instead of plus 4, you're going to translate, or I just use the word shift, but instead of going right 4, that would be positive 4, I'm going shift left 4. And notice when I'm describing transformations, always 3 words. The type it is, this is a shift. The direction, it's going left, because the opposite of plus is minus, so go left. And the number, 4. Type, direction, number. So start with shift left 4. That's the first thing, it's in the brackets. Next thing is do the timesing. That would be the next thing. You do timesing before you subtract. So this 2 is on the y stuff, so it's going with the y-axis, or in the y direction. But it's not a shift, it's a timesing, which means it's a stretch or compression. Since it's bigger than 1, it's a stretch. And that's the type. What's the direction? It's a y thing, so the stretch is vertical, or stretch vertically. And what's the number? 2. You can write the word by. You don't have to, though. It's as long as you've got 3 key things. The type is stretch, the direction is vertically, and the amount is 2. It's a vertical stretch of 2, or stretch vertically by 2. The last thing is take away 1, so it's a shift. But you don't switch the numbers, it's just a y value, so it's shift, and since it's negative, it goes down. And the number in this case is 1. So there's my shift, down, 1. 3 things. Okay, now we actually want to do the transformations, part B. We do transformations by first making an original table, and then we're going to make the mapping rule, and we're going to write the new table. Well, it doesn't even say graph in here, but I think I'm going to graph it. Anyway, let's make the original table. What original table? Well, this is clearly a parabola. Its original base equation, or the parent of this equation, is y equals x squared, the base parabola, untransformed. You can pick any points on that base parabola, but I'm going to pick nice easy ones. -2, -1, 0, 1, 2. Those are your base points on the parabola. And when you were to square them, this is how you get, I just picked easy small integers, and now I square them. -2 squared is 4. Remember, when you're squaring a negative times negative is positive. -1 times -1 is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. That's my base parabola. Now the mapping rule. The mapping rule is like a recipe. It says, take all the points, x and y, so here's all my x, y, x, y, x, y's. I'm going to take them, I'm going to transform them based on this recipe that I get from this equation. This equation says x plus 4, but you always do the opposite of what's happening in the brackets. So instead of adding 4, all the x's get subtracted by 4. And then the y stuff is this times 2 take away 1. So 2 times y take away 1. This mapping rule is going to tell me take all these points and transform them this way using the mapping rule. So let's rewrite that table transformed. This will be a table for this equation, but I generate it by taking all the x's here and subtracting 4. -2 take away 4, -6. Feel free to use your calculator, I won't judge. -1 take away 4, -5. 0 take away 4, -4. 1 take away 4, -3. 2 take away 4, -2. And now all the y's. Take all the y's times 2, and then take away 1. Times 2, take away 1. 1 times 2, take away 1. I'm just doing it in my head, but you can use a calculator. 0 times 2, take away 1. And now we should see that same symmetry again. It's a 1 again. 1 times 2, 2, take away 1. 4 times 2, take away 1. I've got my table. I'm just going to do a quick sketch here just so you can see. I'm not going to draw a graph. Usually when I say the word graph, I mean make a nice scale and accurate graph. When I say the word sketch, though, I just want a rough idea of where this is. The original parabola would have been here, starting at 0, 0 and opening up. Our new parabola, as we expect, has been shifted left 4, stretched by 2, and moved down 1. So these points here, I'll start here with the vertex, which used to be 0, 0. Now it's negative 4, negative 1. So that's about here. Again, just a rough sketch. And then there'll be a point at negative 5, 1. That's about here, maybe. And there'll be a point at negative 3, 1. That's about there. And there'll be a point at negative 6, 7, way up here. And a point at negative 2, 7. I just drew that by starting with the vertex and going either side. I'm going to draw a nice parabola. But it's a very rough sketch. Even there, I wasn't super happy with how that looked. But I just want you to see what we've done here is we've transformed this parabola, which has gone left 4, down 1, stretched by 2, vertically. That's a sketch. I've described the transformations. I made the original table of the parent function, did the mapping rule, made my new table. I even sketched it so I can label that this was B, this was C, this was D. There's a little bit extra. And now part E, state the domain and range. I think being able to see the graph will really help you, again sketch, will really help you do domain and range. The domain here, ask yourself, does this parabola ever stop opening to the left? No. Does it ever stop opening to the right? Now it's going to go forever. Even though it's going to get real steep, it's still going to open up forever. So the domain is the set of X is an element of R. This just means X can be any real number. I'll read that again. Domain is the set of X is an element of, this is not an E, it's an epsilon. Make sure it's curved. The domain is X is an element of R. X can be anything. Not true with the range. The range is what can Y be, and Y starts here and goes up. I'm going to write it starting the same way. Y, these are the Y values, is an element of R. So Y can be any real number as long as you're greater than this bottom Y value. What's this Y value here? How low does Y go? It goes as low as this negative 1. So you've got to be greater than or equal to negative 1. And our symbol in between that is a vertical bar, and we pronounce that such that. I'll close this brace and read it to you. The range is, range is the set of Y is an element of real numbers such that Y is greater than or equal to negative 1. I'll read it again, but more simplified. The range says Y can be anything as long as Y is greater than or equal to negative 1. One more time. Range is the set of Y is an element of R such that Y is greater than or equal to negative 1. We've done transformations of a parabola in depth. We described it. We wrote the parent function's original table. We did the mapping rule and made a new table so we could sketch it. And that made it easier to find the domain and range.